Great, so thank you very much for coming this morning. This is our first morning of senior research projects for 2015. My name is James Kittredge. I'm one of the college counselors here, and I'm also the coordinator for the SRP. So I just want to start by saying how remarkable this class was this year. So this year we have 38 students doing senior research projects out of a class of 63. And it's the largest group of SRPs that we've ever had, and it's also really the most impressive group that I've seen. And I've been at BASIS for 9 years now, and have been involved with the SRP for pretty much every year that I've been here. And they really just keep increasing in quality, and I'm continually humbled by what these students are able to do. So today is our really big day of presentations. We have 4 groups of students that are going today, and they're all sort of STEM-related fields. So this morning you're going to see 3 really excellent presentations, and I'm actually going to let the students' advisors do the introducing for them. So our first teacher is going to be Mr. Matt Belanda, who's going to introduce Helena.
Good morning. Well, good morning. I'm proud to introduce Elena. She's been instrumental in this school community over the last few years, winning Student of the Year in I don't know how many different subjects. I actually do know, but I'm not going to list them off. AP Scholar with distinction. She's got the academic achievements there. When we sat down to do this project, it was quite interesting. She came in and said, I want to do something with bionics. And I was like, okay, let's find something with bionics. And we spent days searching and searching, and we really couldn't find anything. And then we stumbled upon this project, connecting it with bacteria, which was an unlikely connection in my mind. So without further ado, she'll be attending Eckert College in the fall. So without further ado, Elena Herban.
Good morning, everyone, and thank you so much for coming. I am very excited to be presenting my senior research project, which is titled The Intriguing Connection Between Bionics and Bacteria. My name is Helena Herban. I'm a senior here at BASIS Tucson North, and my BASIS advisor was the lovely Matt Belanda, and my internship advisor, who is a professor at the University of Arizona in the Biomedical Engineering Department, was Dr. Wolfgang Fink. So as I continue, I'd like to go over an overview of what I'll be talking about today. First, my research question and why I became interested in it. Second, how I came to the results of my project. The day-to-day schedule and challenges that I encountered throughout, and the results plus the larger significance and personal meaning that I took away from my project. But before I begin, I want to talk about general definitions and explanations of terms that I may use throughout my presentation. First, prosthetic device. A prosthetic device is an artificial device which replaces a missing body part, also known as an artificial limb. Bionics, or a bionic device, it utilizes electronic devices and mechanical parts to assist humans in performing difficult, dangerous, or intricate tasks. The study of bionics itself focuses on replacing functions in nature rather than replicating a biological body part. I'll be also using the term implant. It's any device or material used for repairing or replacing part of the body. Throughout my presentation, I will be using independent research and University of Arizona research. My independent research was research I did using University of Arizona resources such as the library, the books in the library, JSTOR, PubMed, Google Scholar. Now, my University of Arizona research was research I did for the University of Arizona Biomedical Engineering Department, and that was unfortunately kept confidential. So I signed a confidentiality agreement, so I will only talk briefly about various things that I did. Otherwise, I'll be talking about my independent research. So to really start out, my interest. I have really had a passion for bionics because they take seemingly simple movements of moving your arm and show how intricate and complicated they actually are when you're trying to mimic them with electrodes and electricity. So I knew I had this interest in bionics, and I knew my project was going to be about bacteria. So in doing so, I decided to combine them. So I hypothesized at the very beginning that the intriguing connection, or what I call the intriguing connection, dealt with prevention and disease. Now, that was my first connection that I made. For instance, if an individual gets into some type of accident, but a non-bacterial related, so they don't need an amputation due to a due to bacteria, but they need it due to some type of accident. They were in a car accident, a gun shooting, something like that. And during surgery, bacteria may set in due to unclean surgical conditions, or if they're not using an ultra-clean room, things like that. So that was my first connection. So here's my research question. It's how does a bacteria-ubiquitous environment alter the compatibility of and pose complications to prosthetic device and biological body part? Now, for those not biologically inclined, or here's some simpler terms. How does a bacteria-filled environment change interactions between the prosthetic and the bionic body part, the biological body part? So let's dive right into my investigation. Hugh Herr. Hugh Herr is this phenomenal character. He's a professor at MIT and an avid mountain climber. At the age of 17, he climbed Mount Washington and was stuck in a snowstorm. So that caused him to get a double amputation because gangrene had set into his limbs. If we look at this TED, he's giving a TED Talk right here, and he is wearing this biome tissue system, which is a bionic device that he created. Now this was my second connection. If an individual gets a laceration or cut and that becomes infected, then they require an amputation, which then results in a prosthetic device. So that was my second connection that I made. I also investigated history, historical content, the American Civil War. During the American Civil War, there were many, many injuries. Over 30 to 60,000 amputations. Many of the amputations were due to gangrene, blood poisoning, tetanus, diseases like that. They were the most deadly and unfortunately common diseases of the time. Now, during the Civil War, there was a growth of the prosthetic industry. And there was a gentleman, a war veteran, by the name of J.E. Hanger, who I read one of his accounts. He said he looks across the hospital or the surgeon tents that they had, and he said so many maimed soldiers that he knew he had to do something about it. So he created Hanger's Prosthetics and was a really big driving force in terms of prosthetics during the Civil War and beyond. Hanger Prosthetics is actually still in existence today and is a prospering industry. Right here is a photo of a prosthetic industry, a prosthetic factory, and you can see people hard at work building limbs for these soldiers. And my last investigation was prevention, as I mentioned at the very beginning. First, I investigated bacterial growth, not only for my presentation, but also for my University of Arizona research. I also looked at methods to prevent infection with prosthetic devices, and there are 3 guidelines for this: preoperative, intraoperative, and postoperative. Preoperative deals with treating any acute or chronic physical conditions, as well as any skin conditions, and teaching good hygiene to the patients, also reducing hospitalization time prior to surgery. Next was intraoperative. Intraoperative deals with, as I mentioned before, the ultra-clean room, careful skin preparation of the operative site, as well as wound irrigation with a saline or saline antibiotic solution. So this is during surgery. And after surgery, we were looking at the removal of urinary and or intravascular catheters or surgical drains as soon as clinically possible, so that no air or unwanted bacteria enters the body. Sometimes it may be used, it may be necessary to remove the device if it's already been implanted, or the use of an antibiotic. So stepping aside from the hardcore research that I was doing and talk about what my day-to-day looked like. For my independent research, it was a lot of reading journals and looking for sources and searching the web, as well as writing my research paper. I was, of course, looking for my intriguing connection the entire time, and I also updated my weekly blog, which all senior research project doers had to participate in. Fun fact, my blog actually got views across the world, from the United Kingdom, Ukraine, India, Germany, France, Canada, and of course the United States. Lastly, challenges that I faced was finding reliable sources and current sources in a world filled with opinions. So now stepping aside from my independent research and talking briefly about my University of Arizona research. I had tons of fun with this. First, I modeled bacterial growth with differential equations, and this was a great time for me to actually use the math class that I took at BASIS. As well as C coding to support my project, and making tons and tons and tons of graphs with this program called NuPlot. I continually had to familiarize myself with engineering jargon, and by the end of it, analyzing and documenting results throughout my time at the University of Arizona, I had an over 40-page report that I submitted. So challenges that are faced, and there were many, because without challenges, research wouldn't be fun, right? So C programming, that was by far my biggest challenge, because I had never taken a computer science class, and I really didn't know how to use the programming part of computers. So that I had to learn, as well as command prompt. Command prompt is just an alternate way to use your computer. Instead of it being on a graphic basis, it's on a text basis. As I mentioned before, NuPlot, this graph right here is a graph created by NuPlot. It's a 2D and 3D graphing plane. I had to understand how to use that. Differential equations and Runge-Kutta solving method. Before actually starting my research in February, I taught my differential equations class a variation on the Runge-Kutta solving method. And when you actually, when you teach a class, you really have to know the information. So I knew Runge-Kutta method like the back of my hand before ever starting. So that was really good on my part. So lastly was lower computer efficiency, and this was a test of my patience. Because my computer wasn't super fast in processing, when you're taking integrals to 10,000, you sometimes have to wait a long time for a graph to show up. So 30 seconds to a minute, I'd be waiting, and that may not seem like a long time, but believe me, when you're staring at a screen, it's a very long time. I also had to hold down the space bar to get data to go all the way down from 1 to 10,000. And so I actually taped down the space bar at times because I didn't want to hold it down for so long. Okay, so now stepping back out of my ULA research and back into my independent research. Here are my results, many of which I've already shared, but I want to recap and go a little bit in depth with it. So first, bacteria to prosthetics. Any unintended cuts or lacerations that you may get, if they become infected, then you may require an amputation, which requires a prosthetic. Now, how to reduce this? Cleaning wounds on a timely manner, as well as treating any or controlling skin condition. This picture right here to me was really amazing, because this is two brothers before and after war, both of which received an amputation, potentially due to unintended cuts or lacerations, or gun explosions with accidents, which leads me into my next one, which is intraoperative. So if a person needs an amputation due to an accident, such as a gun explosion or a cannon explosion in terms of the Civil War, then you will have to get a prosthetic by the end of it. But if your surgery room is unclean and you are not using proper tools or cleaning the tools properly, then bacteria may set in during surgery. So how do we clean this or reduce this? You're using an ultra clean room, carefully cleaning the wound around the operative site, as well as wound irrigation with a saline or saline antibiotic solution. This photo right here is two gentlemen, one with an eye prosthetic and one without, both of which received gunshots towards their face and messed with their eyes. So both, one without, one with a prosthetic device. Lastly is post-operative. This is broken up into two parts, post-operative to bacteria and post-operative to electrode connection complications. Now first, I'll start with the bacteria. If you are not taking good care of the wounds after surgery, they may become infected. So if wound dressings aren't properly taken care of, if you just have, as mentioned before, the urinary intravascular catheters, if air is unnecessarily in places that they shouldn't be anymore, then this could potentially result in an infection. My second one is very specific because I was reading a case study. So electrode connection complication. I was reading a case study about cochlear implants and bacterial meningitis. So there was a case where children received cochlear implants, but a positioner was inserted in them. And what a positioner is it helps with electrode connections from, for the cochlear implant. And at the very beginning, the scientists thought, okay, this is the reason why the bacterial meningitis set in. But instead, they said, okay, maybe it's not the whole reason. We don't really understand the entire reason of why this bacterial meningitis came in. They hypothesized that perhaps we didn't insert the electrode completely, or there was a presence of a cerebral spinal fluid leak, or the use of an antibiotic, meaning if there's too much, if there's not enough, or if the person has an allergic reaction or something along those lines. So as we see from the case study and with the use of a bionic or an implant, that things are not always known with something so new. So how do we reduce this? Well, the use of an antibiotic, but as we see from the case study, it may not always be the correct option. Removing the device altogether if you've already implanted the prosthetic, because your body could reject it. And lastly, as I mentioned before, removing any urinary and intravascular catheters as soon as clinically possible. Okay, so now here's the recap of all of my research that I just said. So number one, here's my first connection. Any unintended cuts or lacerations become infected, and you need an amputation because of that, results in a prosthetic. 2, during a prosthetic surgery, and you need a prosthetic due to a non-bacterial related accident, then bacteria will set in during surgery. Second connection. My third connection. After prosthetic surgery, you do not take good care of your wounds, and bacteria will set in. Also, the potential removal of the device if your body then rejects it, or if bacteria poses complications for that. All right, now taking it all the way back to my University of Arizona research, and the reason that I'm standing right in front of you giving this presentation is my real-world application to engineering. This was by far my favorite part because it was no longer in the classroom. I was in the lab and working on my computer, continuing my engineering education at Eckerd, so that's exciting. My University of Arizona research really showed that I am actually interested in engineering, and it didn't turn me off to it, which is good. So lastly, and my personal takeaway, was applying differential equations to practical research at the University of Arizona. So BASIS really does prepare you to, do tons of math. They do Calc 1, Calc 2, and if you choose to take differential equations, then you could do that as well. And because you do all of this, you really want to apply it, because you're sitting there working hard trying to understand it, and you say, what's the point? Well, this really gave me a point to learning all of this. And that was really exciting for me to be able to do that. So, before I conclude, I would like to share a few thank yous. First and foremost, Mr. B, for being there, taking me on as an advisee, and showing me how to write good emails and get an internship. As well as, towards the end of my presentation, reading my 15-page paper over and over again. I'm sure it killed him. He's an engineer, so definitely killed him. As well as going over my PowerPoint and being as nitpicky as possible about where the bullet points are on every screen and how they have to match. But if you hadn't done that, then your eyes wouldn't be aesthetically pleased by it. So thank you for that, Mr. B. As well as Mr. Kittredge for being the SRP coordinator and making sure everything runs smoothly. Without you, SRPs won't be the same. Ms. Taves, Ms. Wolford, and of course Olga and Michael Block for giving me this opportunity at the very beginning. I'd like to thank the University of Arizona and Dr. Wolfgang Fink for taking me under his wing, kind of risking it because I was a high school student, not knowing me. I had an incredible time with him, and I have a lot of memories of him, so I'm really excited to be starting my biomedical engineering career, as well as I'd like to thank the biomedical engineering department for taking on a minor and allowing me to work in the lab. But above all else, I'd like to thank my family for being there for me, taking me back and forth for my internship, always being there to support me, and ultimately I wouldn't be here today if it wasn't for your support. So thank you. That is the end of my presentation. I'm looking forward to your questions.
How common are infections during with prostate prosthetics? Do you have any statistics about that, or how frequent does that happen?
I didn't look specifically into statistics because I'm going to say that it happens way more in wartime and historically because we are unaware of how to clean wounds and we weren't aware of bacterial transfer. But when we're using hospitalization and everything is clean, everything is sterile, there's much less cases of it. As I mentioned in the case study, I think that was 26 cases out of 138. So that was for bacterial meningitis and a cochlear implant. But because that's more of a bionic device rather than a prosthetic, it's harder to understand because we're trying to mimic the body rather than just making it look like a foot or something. Yeah.
Why did you take a look at, I guess, the history of it, like the Civil War? Did you want to see how it changed, or?
The Civil War was a time where the prosthetic industry really boomed. So you do see prosthetics in World War II, and you can trace prosthetics all the way back to the ancients, like Grecians, and different stories about like wooden limbs. But that's really where people started realizing, okay, we need to fix or give people extra help when they've lost their limbs. And because there was 30,000 to 60,000 amputations, so many of the young men that were serving in the war were maimed. And so that's really where the whole industry decided to pick up. Yes?
What is your career plan?
My career plan. My career plan is I would like to do biomedical engineering and potentially work in prosthetics and bionics because that's really what interests me. As I mentioned, there's Hugh Herr, and he's been a real inspiration. As far as I know he's doing his labs at his lab is at MIT, and that's really where I want to end up in the end. So hopefully that's the plan, but we'll see. Yes.
Did you look into correlations between, because I imagine you looked at various materials in this process of talking about different prosthetics, like metals to other biological compounds. Did you research at all about the microbiome environments and how those correlate with various materials, and did you notice any patterns?
There was one article that I did read. I didn't focus too much on that because it's hard to create things from that, and that's where research is really going right now, is finding alternative materials to be using rather than metal or wood or silicone, stuff like that. But I did read one article. It was called The Bionic Leaf, and it worked with gold particles that attracted microbes, and it was supposed to be able to draw energy so that it can function things. So I think that's really where it's going. But right now, in terms of materials, they're very synthetic.
Great. Have one.
Your blog is called The Intriguing Connection?
Yes, it's called The Intriguing Connection, and it has tons of my information that I studied and articles I read, as well as some of the challenges I faced throughout my research.
Where did you build that on?
I use everyone doing the SRP used Blogspot, which is part of Google. Yes.
So in one of your connections, when you were talking about post-operative status and stuff, you were saying that bacteria could settle in after the surgery had been formed. So that would be, but after surgery, usually they would close up the wound, right? So would it just be because if it opened up again, or if just something can happen to is that just wound opening is where the bacteria would settle?
Yeah, so there's that if the wound was to open up again, or stitches were not properly done.
Okay.
Also, as I mentioned, not removing catheters, intravascular catheters, that could potentially have air or bacteria that could go into your body and infect. Also, going back to the Civil War, there were times where the nurses, because they didn't understand how bacteria was transferred, they would actually take wound dressings from one soldier to the other soldier, and if you do that, then you run the risk of moving infection from one soldier to the next soldier.
Thank you, Helena. All right, so without further ado, I'm actually going to call Mr. Belanda back up to introduce Miles.
So I don't want to give everything away, but Miles built a robot that moves